Okay, so question 15, there's 4 parts to it. Show that the equation x cubed plus 7x minus 5 equals 0 has a solution between x equals 0 and x equals 1. Okay, if you want to ever show that there's a solution between two values of x, you need to sub them both in. And if there is a solution between them, there should be a sign change between your two answers. So let's see what that looks like. If we treat this as like a function, so let's say f of x is equal to x cubed plus 7x minus 5. If I work out what I get when I sub 0 into this equation, so 0 cubed plus 7 times by 0 minus 5, gives me minus 5, which is negative. And if I do f of 1, so 1 cubed, should really put these in brackets because we're replacing x, 1 cubed plus 7 lots of 1 minus 5, that gives me 8 minus 5, which is 3. Now, the solution for this is when it equals 0. If one of these is negative and if one of these is positive, somewhere in between when x is 0 and when x is 1, you'll get something that makes it equal 0. 0 is somewhere in between these two values. So the value that 0 gives you is slightly too small, below 0, and the value that you get when you sub 1 in is slightly too big, it's above 0. But the fact that there's a sign change shows a root between, just getting a bit out of focus there, x equals 0 and x equals 1. Okay, now for part B, I don't think there's really an excuse for not trying this because you're just rearranging this equation until it looks like this. They actually tell you what you need to end up with. You're not making x the subject in this case because you're going to end up with x's on both sides of the equal sign. That's a pretty good clue that it's going to be something to do with iteration later on. Some of you just didn't show enough stages when you were rearranging this. Some of you, because you knew what you were aiming for, just put some bogus explanation and some very vague steps about how you got there. So, easiest way to do it, if I add 5 to both sides, and then if I factorise an x out of this, so I've got x squared plus 7 on that side, and then divide both sides by x squared plus 7, you have now shown that this can be arranged to give you this, which is what you were looking for. But you've actually shown every step. Going from here straight to here is not a good way of showing it. This step here is kind of the one that shows that you know what you're doing a little bit. Okay, but when you rearrange something, you've still got x's on both sides. Like I said, chances are you're going to be using it for iteration. So you'll see that this formula, the x by itself, has now just been made x n plus 1 for this iteration question, and the x on this side has been made into xn. So how do we use this? Well, if x0 is equal to 1, then for my first term I'm just going to do 5 over, I'm going to sub my previous term in, because that's how we do it with iteration. I'm going to sub my previous term, which is 1, in where it says x to the n, so 1 squared, and you've got the plus 7 on the bottom. That gives you 5 over 8, which is 0.625. It says use the iteration formula 3 times, so I need to use it a couple more times. A reminder, when you're using your calculator with iteration, you can just put in your first value. So if I press 1, let me try and get that in the light, press 1 and then equals, my calculator now has 1 stored as the answer. And then I'll use the answer button to start writing in the formula that I want. So I've got 5, so without pressing anything, so that the answer stays in there, I'm going to do 5 over, I'm going to put the answer squared, and then plus 7. So if I hit equals there, it subs 1 in, it gives me this 5 over 8, or the 0.625, which is what we've already got. But because I've got my formula written in terms of answer, if I press equals again, it will sub this in. So I'm going to hit equals again. Gives it me as a fraction. So if I wanted to put it in as a fraction, I could do 320 over 473 but as a decimal, if I press SD, it's 0.67. I know I'm putting in a lot of decimal places here, but in general, you might lose marks if you round an answer too much. Or if the question specifically tells you how much to round it, and you don't do it, you don't follow the instructions for rounding it in the question, you can lose a mark. But apart from that, you're always better to leave your number longer rather than rounding it too much. If you round it too much, you can lose marks. Okay, but I've still got my formula in there with the answer. So if I press equals again, it will then just sub this number back into that. So I'm going to hit equals, and now I've got 0. A lot of you rounded this too much. 0.670448300. I might just write the whole thing out to be safe, but as far as an answer, as long as you had 0.6704, I believe, you got 4 marks for it. Okay, this actually has a part D. By substituting your answer to part C into this, comment on the accuracy of your estimate for the solution. Okay, so that means if you sub in your answer to part C into this, if it was really, really accurate, if it was actually the solution, it would come out as 0. But as it's an estimate, it's probably not going to come out as exactly 0, but let's just see. So the previous page, when I did this answer, I put it in as 0.6704. So, if I use that now, 0.6704, I'm just going to write it here so I don't forget it, 0.6704. I'm subbing it in, so instead of x cubed, I'm doing this cubed. This is my estimate for the solution. Let's see how close it actually gets us to 0. So if I use 0.6704, and I sub it in, so I've got, instead of 7x, I've got 7 lots of this number, and then minus 5. I can go back to my calculator, and I can say, right, 0.6704 cubed plus 7 lots of 0.6704 minus 5. And my calculator tells me that times 10 to the minus 3 at the end means that this decimal point will actually move 3 places this way. And if I do that, the number that I actually get will be minus 0. So the first movement will take it just in front of the 5, and then the next 2, so I'll have 2 zeros in there. So if I times this number by 10 to the minus 3, if I move this decimal point 3 places this way, I get minus 0.00589 8 if I round it, because it's 79. Okay, now this, the question does actually specifically say, let me pull this down a bit, comment on the accuracy. Right, if you've substituted that in and you've shown this value, you've got a mark, but comment on the accuracy, very close to 0, because the solution, if you sub in, the value of x that actually made this 0 would be the solution. But your estimate, which you've done from your previous question from part C, gives you something that is very close to 0, which means that so therefore my estimate is quite accurate. It must be pretty close to the solution. It must be pretty close to the number that actually makes this equal 0. Okay, so it all ties in together, because looking back to part A, we showed that there was a solution between 0 and 1. And in the end, after using iteration, we've estimated it to be 0.6704, which is between 0 and 1. And when we've got to this estimate, we've shown that it's pretty close to actually being the solution. It's supposed to give us 0, and it almost does.